In this video, we're going to be doing some problems on motion. Okay, this is mainly a calculator required problem set. So let's get the graphing calculator out. Okay, number 1A, a particle moves up and down the y-axis according to the position equation in the sky for t greater than 0, which position is in centimeters and time is in seconds. When is the particle moving down on the interval 0 to 5? So go ahead and try this one first on your own. This is a follow along type of video. All right, so what did you get? How'd you use the calculator for this? Well, you could just simply graph this guy and see when it's moving down. That's totally fine. Okay. Another way to do it is we can differentiate this, take the derivative of y, so y prime, set it equal to 0, and then find out when the derivative is negative. That's when it will be moving down. That's two ways to approach this. Okay, so what did I do? I used the derivative way. So, as I said here, y prime is less than 0. We're going to find when that is. Okay, so this is how we can use the graphing calculator. I'm assuming this is like the TI 83, 84, whatever series. I remember this is the command, something like this. So in the graphs, equations of the graphs, we set y1 equal to this guy. I didn't type the whole thing, but we would replace this t with the x instead, okay? And then we set y2 to be n derive of y1 comma x comma x. So derivative of y1 with respect to x, and we want it as a function of x, okay? So let's just graph y2. You don't need to graph y1, and you see when it's negative. So this will look something like this. Okay, we're only interested in 0 to 5, so set your window from 0 to 5. Okay, and we see that it's negative when t, or yeah, t, I'm going to say t is between 0.738 and 2.499. Okay, and again, from 3.613 all the way to 5 seconds. Okay, so notice how if we use the calculator properly, we don't actually need to, by hand, find the derivative of this guy. If we know how to use this n-derive command, all right? It's not bad at all to find the derivative of this. You just need to product roll, but it takes maybe 20 seconds. Then you got to check your work. Versus you just type it in, takes maybe 5 seconds. Double check that you typed it in correctly in another 2 seconds. And then we do n-derive, which takes, I don't know, 2 seconds, 3 seconds if you're used to using this. All right. So don't bother finding a derivative here in this particular problem, at least. All right. 1B, same prompts, but at what values of t is the particle moving at a rate equal to the average rate of change for the particle on the interval 0 to 5? Ooh, what's average rate of change? So go ahead and try this on your own. This is essentially asking when is the instantaneous rate of change equal to the average rate of change? Does this sound familiar to one of the theorems? The mean value theorem basically is asking you to use the mean value theorem here. Okay, but we don't really need to know that. It's the mean value theorem, but that's what it's asking. Okay, so what's the average rate of change? It's just the slope of the secant line between those 2 points. So y of 5 minus y of 0 over 5 minus 0. You need to calculate for this for sure. It is negative 0.57535. Okay, so this is how we use the calculator. Okay, we set y3, so we keep our y1, y2 from before. Don't get rid of them. We set a new function or new y curve, y3, to be this value here. Okay, we're going to graph it along with y2, and then we're going to find out where they intersect. Okay, basically we're essentially solving for when y prime equals this value. This is one way to set it up. Or you can set up y3 as y2 minus this guy and find the zeros. So it'll become a plus because minus negative, okay? And then you find the zeros. So you can set it up like that as well. Or you can set it up like y2 is what we already had. Y3 is, so you could type less this number, find the points of intersection. Okay, so we see that on the interval 0 to 5, the mean value theorem, remember it says at least 1C, the mean value theorem. So there's actually 3 points over here in which the instantaneous rate of change is the average rate of change. Okay, so those are the 3 points. Part C, same prompt, but now it's asking at what time or times is the particle exactly 2 centimeters away from the origin on the interval 0 to 5. Okay, so how can we use a calculator for this? It's 2 centimeters away when y is equal to 2 or -2. Okay, so we graph our y, which is y1. We already had it in our calculator. Hopefully you didn't delete it. Now we use y4 as 2, y5 is -2. Find the points of intersection again, because we're essentially solving for t when y is equal to 2 and -2. Okay, so you would get these points here. Those are the times. Okay, gotta know how you use that calculator. Number part D, what is the acceleration of the particle the first time it comes to rest? Okay, so acceleration, so we probably need to do the second derivative, okay? So first of all, the first time it comes to rest, when does it come to rest? I think we had it from, or we can use y prime, which was y2, okay? The first time it comes to rest means when the velocity is 0. Velocity would be y prime, okay? So the first time is 0.738, okay? So we need to first do that. And then we use, so just go into regular calculator mode. You don't have to graph this. So we do this in a calculator and derive y2, which is y prime, okay, comma x, comma 0.738. So what is this? What does this mean? This means we want the derivative of y2 with respect to x at the value x is equal to 0.738. This is essentially that since y2 is the first derivative, we are asking the calculator to help us find the second derivative of y with respect to x at x equals 0.738. And why do we want that? Well, it's asking about acceleration. Acceleration is the second derivative. So don't need to do it by hand again. Use the calculator to help you out. So you can just evaluate this right away. So notice how when we graphed it, we replace this third argument, this third input with x, because we want a general number x. We want an arbitrary number x so that the calculator can plug in different values of x and graph it. Whereas here, we're only interested in one particular value, so we can evaluate it right away. We don't need to graph it. Okay. Part 2, and the problem 2, part A. Assume a rifle discharges a bullet with an initial velocity of 3,000 feet per second from a height of 6 feet. How high will the bullet travel at its peak? Okay, so this one is the more interesting one with the calculator. It might be actually easier to do some of this by hand. So let's see what's going on, okay? So first of all, we got to set up an equation for the motion of this bullet. So usually I feel like they give it the acceleration due to gravity and all that, but if not, you got to memorize it, okay? If you take physics, this is a basic kinematics equation. This is in feet, unit of feet. This is the imperial unit, if I remember the terminology correctly, not the SI unit. So we got to use like acceleration due to gravity is minus 32 feet per second squared, if I remember correctly. So it should be something like this, okay? Where y0 is the initial position, v0 is the initial velocity. Okay, so we plug it into pieces because we have the initial height, the initial position, and the initial velocity. Okay, so this is our equation. Now, what's it asking? How high will the bullet travel at its peak? So it's asking what's the maximum height. So how can we get that? Well, one way is you can just graph y equals this and find the max. Your calculator can find max min, the TI-84 at least I know for sure can, TI-83, 84. Okay, and if you graph that, you'll find that the max occurs at 93.75 seconds, and the y value is 140,631 feet. Okay? However, if you try to do it like this, and your calculator doesn't have like an auto window function, good luck setting the window manually, because notice how we had to set our window, our y value to at least 140631. Okay, and then our x, we had to set it to at least 93.75. So good luck setting that manually. Okay, but this is one way that you can approach it. Method two is, well, it's at its max height when the derivative is zero. Okay, because you can imagine as it goes upward, and then it stops, right? So when it stops going upward, the velocity is zero. So we can find when y prime is zero. So like before, set y1 to be our model for the position. Y2 is n derived, y1 comma x. And you find when y2 crosses the x-axis. So x is 93.75, something like that. Okay. And then after it, you go, because we're asked how high, so we got to plug t as 93.75 into our y1. We're asked for height. So you still need to set the window successfully because you still need to be able to get that x is 93.75. So you have to at least set it to 100 or something like that, probably. Okay. So this is honestly just easy to solve by hand. Okay. Because it's a polynomial and it's a quadratic. This is our function right here. We take the derivative. It's minus 32t plus 3000. We set it equals to 0. This is a linear equation. We can easily solve for t. T is 93.75 seconds. So honestly, this one was probably just easier to solve by hand if you're struggling to set the window. Okay. Actually, we don't even need calculus to find it besides method one. There's another way to do it. Remember, this is a parabola. This is a quadratic, so it's a parabola. The max would occur at the vertex of the parabola. Do we know the formula to find the vertex? We do, at least the x-coordinate. It's easy to remember, or the t-coordinate in this case. Remember this formula? Negative b over 2a when it's in standard form, at squared plus bt plus c, or ax squared plus bx plus c. The x-coordinate of the vertex would be negative b over 2a. This is in terms of t, not x. So t is minus b over 2a, which you get 93.75 seconds again. All this to show that there's lots of ways to think about this problem. You can think of the calculus method with differentiating, or you didn't need to. You could just graph the original guy, since this is a calculated problem, or you can use what you learned in algebra. Okay, part B. How long will it take the bullet to hit the ground? Okay, it hits the ground when y is 0. Okay, since we already had part A, where it's at its max at 93.75, okay, we can probably set our window a little easier. We have to go for sure beyond 93.75. Maybe set to 200, to 300, something like that. You'll probably see it, okay? So we graph y, we set our window properly, and then we see, oh, it crosses over here. So it is at t is 187.502 seconds. Okay. Part C, at what speed will the bullet be traveling when it slams into the ground, assuming that it hits nothing in its path? So it's asking for speed, which means we probably need to do something about with the velocity. How do we get velocity? It's the first derivative. Okay. So since this is not too bad to do it by hand, we can do it by hand. But okay, so it hits the ground. We found it, right? At t is 187.5 from part B. So we want the velocity or the first derivative at 187.5 seconds. T is 187.5. So since we had y prime earlier, we can just plug it into minus 32t plus 3000. So that's minus 3000 feet per second. Or you can do the calculator. Y1 is our model. prime of 187.5. That's what we're trying to find. We do n derived of y1 comma x comma 187.5, and you should get minus 3,000 feet per second as well. This is asking for speed, not velocity. So we just take the magnitude of this, or absolute value of this. The speed is 3,000 feet per second. So the velocity is speed with direction, positive or negative. Speed doesn't tell you the direction. Okay, part D, last one. What vertical distance does the bullet travel in the first 100 seconds? Be careful with this one. So in the first 100 seconds, well, let's go back to part A here. So from 0 seconds to 93.75 seconds, it traveled this much feet, this many feet, 140,631. Okay. So it traveled at least this, and then it starts going down. So we need to count how much it went down. Okay. So we want y of 100 because we want the position, the height at time t equals 100. Okay. So let me scroll back to part D. Okay, so that's what I said here. So y of 100 is 140,006 feet. So that means from 93.75 to 100 seconds, how much did it travel, or how many feet did it travel? It's the difference from the max height minus what we just found. That's 625 feet. So in total, it traveled 140,631 plus 625, and that is 141,256 feet. And that's our answer. All right, that's it for this problem set. Hopefully this was good practice using the calculator, and hopefully I was able to clarify something if you were confused about something or got stuck on something. Please give this video a like if it has helped you in any way, and hopefully I'll see you in another video as well. Bye.